Sorry, children who don't follow directions. Okay, so synonyms. They might say that the figure is flat. They might say it's plane, as in flat. Or even better, they may say it's two-dimensional. Two, as in the number TWO, dimensional. DI, men, MEN, shin, SION, ol, AL. So these are synonyms for flat. Plane, flat, two-dimensional. And two-dimensional, I want y'all to bring that over here, 2D. That's what a lot of time, I'll ask kids what 2D means, and kids will tell me 2D shapes are flat. Yeah, they are flat. And if I ask them why, this is where no one knows why, because we just allow things to go without like some explanation. 2D means they have two dimensions that are measurable. You can measure a 2D's length and a 2D figure's width. And I would get up to go make sure the kids have written everything you have. So, and I would be talking as I'm walking around. So when we say two-dimensional, we're saying that it's a figure that only has a side measuring length and a side that you can measure width. And then I go and hold up a piece of paper. Y'all say 2D figures are flat, and you're right. And it's because all you can measure on a flat figure is its length and width. Which is why when you ask kids what a 3D figure is, and they go, oh, well, it pops. Well, 3D figures pop because 3D figures have length, they have width, and they also have the third dimension of height. I usually grab a tissue box for this, and I kind of repeat that one more time. 2D means two sides are measurable, a length and a width. If you only have length and width, you're flat. If you add a third dimension, a 3D third dimension, it could be depth, it could be length, width, and how deep it goes or high. It adds that third dimension and makes it pop, so to speak. So I always take some time to talk about that. Now I've lost my pencil. There it is. All right, so a polygon, look at these. I want y'all to look, just don't write, just watch. So polygons have to be flat figures. They have to be closed. They have to use straight edges, and their sides cannot crisscross. They can meet, but they can't cross. So again, y'all look. It could be plain, as in flat, straight-edged, closed, no crisscrosses. These are polygons. Regular, which you probably have to fix that too. Regular polygons, which to me, when I see someone that's regular, I think of normal. Regular polygons have congruent edges and angles. Let's highlight that. Congruent, same size, same shape. They're what we consider normal. This right here is a regular, let's write it down, polygon. Write it and then I'll explain why. It's a regular polygon because the edges, this side, this side, this side, and this edge, they're all congruent. They're all the same size, same shape. We should know that about squares. The angles, what type of angle is this one right here, this L? Yep, it's a loser. What kind of angle is that? A right angle. And that's an upside down loser and a backwards upside down. So all the angles are right angles. So if the edges and the angles are congruent, same size, same shape, you would call it a regular polygon. So you're going to see most of your teaching, it seems like a simple lesson. This takes a long time if you're doing it well. Irregular, y'all say that prefix ear. I say E, sorry, ear. Irregular. If I see a kid that's acting irregular, they're kind of acting, well, that looks like he's drooling. Irregular, here, let's draw it like this. An irregular kid or someone, they're the kind that are kind of weird. Some odd. There's some regular peoples over there that I hang out with, and then there's these irregular ones like Miss Pierce. Irregular polygons, let's highlight this part, do not have congruent angles and edges. They are not normal. They're still a polygon, but they're not normal. Nothing on this side would be irregular, so I want y'all to flip to the back. For example, right here. Is this edge the same length as this edge? No. What kind of angle is this? What type? Yep, that's a 90-degree right angle. What kind of angle is this right here? He's a cute little angle. He's less than 90. So if the edges or the angles or both are not congruent, not the same size, not the same shape, we would call it an irregular polygon. So prefix IR, irregular polygon. It's still a polygon. It's a polygon because it's flat, it's closed, the edges are straight, and it doesn't crisscross. But it's an irregular one because there are things that are not the same about it. And I'd get up and kind of repeat myself as I checked on, did the kids do what I said? All right, let's go back to the front. So we're going to name them. Congruent, by the way, means, you might have already done this, same size. This is what we've been talking about. Same shape. Edges are the sides. So basically all I was doing was taking some of this difficult vocabulary and breaking it down for some kids. All right, y'all know this one. Y'all have known this forever. What is this? A triangle. All right, let's spell it. T-R-I, angle, A-N-G-L-E. Make sure you spell angle and not angel, A-N-G-L-E. Triangle. I want y'all to highlight the prefix tri. Tri means 3. Tricycles, how many wheels? 3. If you know dinosaurs, a triceratops has 3 horns. Triplets, how many babies? 3. So when you're looking at a triangle, you know everything about Mr. Triangle is 3. There are going to be 3 edges, 3 angles, 3 vertices. So let's prove this with our highlighters. What are edges, by the way? Oh yeah, right here. What's an edge? Edges are sides. All right, we're going to highlight and count. So it doesn't matter which edge I'll start on, but we'll go like this, like 1. Are y'all with me? Keep going. 2, 3. 3 edges. Angles. Angles are where 2 edges connect and form like a corner right here. What is this one? Acute angle, A. What's right here? Acute angle. What about right here? Another acute. So 1, 2, 3 angles. By the way, if they're all acute, what type of triangle is this? He's a cute triangle. So I'm going to add that. See how I'm connecting other concepts? Acute triangle. Because when you're cute all the way around, you're a cute little triangle. Now, back to the point. 3 edges, 1, 2, 3. 3 angles, 1, 2, 3. 3 vertices. Here's how we prove vertices. Vertices are the points or the corners of where 2 straight edges meet. So we're going to put a point. 1, 2, 3. 3 vertices. And I want y'all to do a little point so y'all know that the vertices are these points. If you're talking about one vertice, you're talking about a vertex. One vertice is a vertex. So if I said go stand in the vertex, I'm basically telling you to go stand in the corner where the walls meet. That's singular. Vertices is plural. What does that mean? More than one. That's right. And again, seems simple, but it really needs to be explained. All right. What is this? A square. Yes. SQ. Oh, no, sorry. They're going to say square. We're not going to call it a square. We're going to call it a quadrilateral. Q-U-A-D, quad. R-I, lat, L-A-T-E-R-A-L, quadrilateral. Y'all say that. Say it again. Quadrilateral. The prefix quad, let's highlight it. Quad. Quad has 1, 2, 3, 4 letters. Quadrilaterals are polygons that have 4 edges, 4 angles, 4 vertices. Did y'all hear me say that this polygon? Why is that a polygon? Well, let me look back at my notes. This is a polygon because it's closed. There's no openings. It's a polygon because it has straight edges, straight sides. It's a polygon because it's flat. and there's no crossing of the lines. They meet, but they don't cross. This is a polygon. When the polygon has 4 edges, it's a quadrilateral. If the polygon has 3 angles, it's a triangle. So you're able to name polygons by their edges, angles, or vertices. So we said this, but let's prove it. Let's find vertices. So remember vertices, there's a vertex, 1. All right, prove your vertices. 1, 2, 3, 4. All right, edges, what are edges? Sides. All right, let's highlight and count. 1, 2, 3, 4. We already talked about the angles. You've got 1, 2, 3, 4 right angles. Everything about a quad, Q-U-A-D, 4 letters, is 4. It is a square, but it's also a quadrilateral. Kind of like yours, and he's a polygon too. So this is where I like to get mathematically nerdy, y'all. Polygon, I'm closed, I'm flat, straight edged, I'm a polygon. But I'm also a quadrilateral because I have 4 edges. But my name is square. It's kind of like students, I tell them. You are a 4th grader, so you're in this big category, but you belong to Miss Simon's homeroom, but your name is John. So we can belong in many groups. All right, this one. Well, if this is 3 and this is 4, what do you want to bet these are? 5s. Yeah, let's just go ahead and write that because I know y'all already probably have. Let's not lie. All right. This guy is a pentagon. It's pen, P-E-N, T-A, gon, G-O-N, pentagon. And I want y'all to highlight penta. Penta. Penta is 5. I think about like this. See my pen? If I grab my pen, how many fingers do we use to grab? 5. When you grab pens, it's 5 because it takes 5 fingers and it's a pentagon. All right, let's prove 5. Let's grab the edges. 1, and it doesn't matter what order you start, but you should be doing it. 2, 3, 4, 5. Vertices. 1, 2, 3, 4, 5. Edges. Angles. What type of angle y'all think that is? Right, acute, obtuse. They often get confused on these. I don't blame the kids. Here's what I would do. I always tell them, if you're not sure, draw a right angle. Like start right here on the bottom. Go straight up and draw that capital L. We know losers are right angles. So if this is a right angle and this edge opens up bigger, what kind of angle is it? It's obtuse. Yeah. And this is obtuse, 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 obtuse. 5. 1, 2, 3, 4, 5. So 5 fingers, pen. Grab your pen. 5 is pentagon. Now here's what's really cool. So penta means 5. By the way, the Washington building, you might even bring this up on your Google Drive, y'all, or on Google Images. Pentagon, the building of a pentagon is shaped like this. From the air, it looks like a pentagon. I would actually have that ready to show. Here's the other neat part. Gon, the suffix, the ending. Gon. What is the word that we were talking about up here? Polygon. Gone. Polygon. Gone. This is a polygon. Why is it a polygon, y'all? Right, it's closed. Good. Why else is it a polygon? Straight edges. Good. What else? Flat. What's a synonym for flat? What else could I say? Plane or 2D. Very good. So it's a polygon. How do I know it's a pentagon? 5 edges. Yeah, if it has 5 edges or 5 angles, it's penta, 5. Gon means I'm a polygon. So here's how this dude is working. He's like, dude, I'm a polygon. I'm flat. I'm straight edged. I'm closed. And because I have 5, you call me pentagon. So it's using penta and gon. Yeah, I like to talk weird when I do this. So yes, we know it's 6, 6, 6. 6. Spell it. S-I-X. Grab the X. 6. When it has 6, it's a hexagon. Hexagon. See that X? That's how I always remembered the 6. 6 has an X, hexa has an X. I want you all to circle hexa. Highlighted, I mean. Hexa is 6. Let's find 6 vertices. 1, 2, 3, 4, 5, 6 vertices. How many do you think there are 6 edges? Yeah, and we don't have to keep doing that. I do that more for the vocabulary at this point. So if it has 6 vertices and it's a gon, as in a polygon, what it's saying is I am a flat, closed, straight edge shape with 6. That's why I'm a hexagon. But if I'm a polygon with 5s, I'm a pentagon. Fill in 7s. Hepta. H-E-P-T-A, heptagon. Hepta. Highlight hepta. Hepta means 7. We talked about how these are also septagons. I would not mention it to the kids. I would not use that because if you look at testing or anything like that, they're going to be using heptagon. All right, how can we prove this is a polygon? Right, it's a gon. How can we prove this is a polygon? Okay, yep, straight edges. What else? I don't want to hear flat. Something else. 2D, okay, what else? Closed. So you can see how I'm going to keep knocking that these are polygons. And why? These are their attributes. So how can I prove that it's a hepta? A 7-sided polygon instead of a 5-sided. Count vertices I could. What else could I count? Edges. All right, let's highlight edges and count. 1, 2, 3, 4, 5, 6, 7. So if you're a polygon with 7, you're a heptagon. I always remembered, 6, 7. 6 has the X, hexa. 7 follows with hepta. Hepta. All right, 8. What do you know has 8 tentacles? An octopus. Yep. Octagon. Henry, what do you think octa means? 8, yep, like an octopus. Phoenix, what do you think gon is standing for? Polygon, very good. John, give me an attribute of a polygon. Straight edges, good. Lily, give me another attribute of a polygon. Closed, very good. Tony, what's another attribute? They're closed, straight-edged, flat. Very good, y'all. So he's a polygon. Octa because why? 8. So how can I prove that this is an octagon? I could count the edges, right. What else could I count? Vertices, good. What else could I count? Angles. Let's look at angles. What type of angle is this right here? Yeah, that's obtuse. So let's count. There's 1, 2, see how I'm doing this? 3, 4, 5, 6, 7, 8. So if I need to name a polygon, I could count edges or angles or vertices. All right, let's look right here. What numbers? 9s, yep. 9, I want y'all to spell it for me. N-I-N-E, 9. 9, nona, N-O-N-A, gone. Why is this a polygon, everyone? Flat, closed, straight-edged, good. Highlight nona, 9, nona, 9. So how can you prove this has 9 something? Count the edges. All right, let's highlight edges. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. And y'all can see that my shapes are not naked. I'm showing my work like I'm always expected to. 10s. I want y'all to write decade. D-E-C-A-D-E, decade. Then I want y'all to write decagon. D-E-C-A, gon. I want you to highlight the prefix, deca. Deca. Deca means 10. If I said that I've been alive a decade, some of you, if you've turned 10 this year, if you've been alive a decade, you've been alive 10 years. So if I said I've been alive 3 decades and 7 years, how old am I? 37, that's right. What if I told you my grandmother's been alive 9 decades and 1 year? 91, very good. Decades are 10 years. Decagons are 10-sided. Yes, polygons, very good. How do we know it's a polygon? Says gone or flat, right? 10, what can we prove it has 10 of? Vertices, all right, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices, plural. If you're talking about one of them, one vertice, singular, vertex. All right, now these you're not probably going to see on a test, but I think it's really cool. So 11, UN, deca, gone. Un, deca, gone. I want y'all to circle un and write uno. I want you to highlight deca. And then we've got that gone. Why does it say gone? That's right, because he's a flat, closed, straight-edged polygon. He's a polygon. What did we just say deca or decades are? 10. And when y'all play uno, how much is uno? 1. So un deca is 1 plus 10, which is 11. Un decagon. Let's find angles. 1, 2. See how I'm doing this? Look up. All right, let's keep going. 3, 4, 5, 6, 7, 8, 9, 10, 11. Un deca. 12s. I want you to write DOS, deca, gone. Circle dos. Yes, y'all know those who speak Spanish, dos is 2. Deca, you highlight. What do we know decades are? 10s. So a dodecagon, dos deca, uno dos, 2 plus 10 makes 12. These are all polygons. So I would get up, go check that your kids did everything you're supposed to. If they didn't, hold them in at recess. Hold them accountable. Of course, ED kids, a little different. But as you walk around, go, these are all polygons. They're all flat objects. They're all closed. They all had straight edges. Now let's flip to the back. Read me the directions, guys, as a whole class. Identify whether each image below is polygon. That should say or not. Let's fix that, y'all. All right, boys, read the next line. If it is a polygon, name it, label it as regular or irregular. So that's 3 directions. If it is a polygon, we have to name it and label it as regular or irregular. Remember, regular means I'm very normal and irregular means I'm very abnormal. I could look back at my notes. Regular means congruent angles and edges. Like everything was equal, same size, same shape. Irregular, not normal, because the angles are different, the edges are different. Is this so girls, what about the next one? If it is not a polygon, justify your response. Justify, I want y'all to circle that. If it is not a polygon, prove it. That's what they're saying. All right. So, Lincoln, do you think this is a polygon? No. I agree. Let's put an X. Sarah, why is this not a polygon? Right. It's open. Why else? Not straight edged, is it? So, instead of saying not straight edge, let's say it's curvy, right? Oh, and it crosses. So it is not a polygon. It's got an opening. It's got curvy edges. It crisscrosses lines. Not a polygon. Is this a polygon, Moses? Yes. How do you know, Moses? Yeah, it's flat, straight edge. All right. It is a polygon. If it is, we have to name it and label it as regular or irregular. Well, regular. Are all the edges the same lengths? No. All right. So this is definitely irregular. Not that it doesn't look like a normal shape. I can tell it's a plus sign. Irregular because not congruent, not same size, not same shape. Okay, and Lacey, how are we going to know what to name it? It's a polygon. How am I going to know if I should call it a hexagon or nonagon or... Okay, I can count what? Vertices. Okay, let's count vertices, y'all. It doesn't matter where you start. Everyone, let's find vertices. 1, 2, I should hear all of you counting. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Flip back to y'all's notes. If it's 12-sided or 12 vertices, what is it? Dodecagon. Yeah, dos, D-O-S, as in uno, dos, as in 2. Deca, like if you've been alive a decade, 10. Gon, as in I'm a polygon. Dodecagon. You don't say the S. Dodecagon. Get up and go check on them. All right. Kylie, is this a polygon? No. All right, let's put a big X. All right, justify your response. So help her out, Dallas. How does she know that's not a polygon? Ooh, that's not a straight edge. Yeah, and y'all are going to hear a song in a minute that says, if there's a curvy one, it's not a polygon. If it's curvy, not a polygon. But it is flat. All right. Is this a polygon, class? I agree. No. JD, why is it not a polygon? You're right. Because it's not two-dimensional. It is not flat. Do y'all remember what I said dimensions were? Give me something you can measure. Give me one dimension you can measure. Yep, you could measure length. You could measure width. Yep. Or height. That's 1, 2, 3 dimensions. Is this a polygon? How do y'all know this is a polygon? Straight edged, yeah. Closed, yes. How else? Flat, I don't even remember what I missed, but you get it. Okay, is it regular or irregular? Why do you say it's regular? Because it looks normal? Well, that's not the definition. What about the angles? What kind? Acute, 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 acute. Yeah, that's true, but what about that angle? That's not acute. What is that? Oh, y'all, look at that. And this is why angles can be tricky. So are all the angles congruent? Are they all same size, same shape? Nope. So we're going to have to call this guy irregular. It is a very normal looking star to you and I, but because not everything is the same size, same shape, it's irregular. It's a polygon. We said that. How do I know if it's a hexagon or a septagon? Not septagon, heptagon. We could count the vertices. Yeah, what else could I count? Let's count the angles. So we said there's acute ones. 1, y'all look at mine. 2, help me count. 3, 4, 5. But then on the outside, 6, 7, 8, 9, 10. What is this? Yep, if you've been alive 10 years, you've been alive a decade. This is a decagon, as in a 10-sided polygon. We already know this is irregular. We talked about how there are not congruent edges. And let's name it. What should we count? I could count vertices. What else? Angles. I really don't like counting angles. They're confusing. Like sometimes they're inside or outside. What else? Edges. All right, you could highlight or you could just like grab them like that. 1, 2, 3, 4, 5, 6, 7. 6 with the X is hexa. After hexa comes hepta. 7 is hepta. Heptagon. And of course, y'all could look on the back, but I like to show them hexa, hepta. 6, 7, hexa, hepta. Is this a polygon? Yes. How do we name it? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is going to be an undecagon. And it's going to be labeled irregular because not same size, not same shape, not congruent. They should say, yes, it's a polygon. That's acute, acute, acute. But look at that. Obtuse, obtuse. So irregular. I get them to count angles on this. So 1, 2, 3, 4, 5, 6. 6 with an X. Hexa. Hexagon. No, not a polygon. Why? Yeah, because it intersects. Crosses. Crisscrossing. Or intersecting would be even a better word. Since y'all have done those lines, they touch, they meet. Polygon? Yes. Tell them why. Flat, closed, okay. Regular or irregular? Are these congruent? Yeah, they're same size, same shape. What type of angle? Yeah, 90 degrees. What type of angle is this? It's another loser. So this is regular. How do I name it? Let's do vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dodecagon. No, if there's a curvy one, it's not a polygon. No, if there's an opening, you better look again. After you go through your notes before the assignment, there's no assignment today, is there? I don't remember. Y'all know. After you go through the notes, my math DVD, I know it's easy for Kylie and Ashley to share because they're side by side, or it'll be you, Kinsey, tomorrow. There's a Polygon song, and I would totally play it because it's really good it's a catchy one, and it reinforces everything you talked about today. And, of course, if you have time or no one's, like, beating at your door for the DVD, you could even play the angles, since you have to use acute, obtuse, and right with this. Y'all might even look on YouTube for some different ones. I think I did share a few. I'll look back, just in case, like, you can't get my math DVD. But these are tomorrow's notes.